Hello, team. I'm going to present my project as part of the second presentation from the Data 670 Data Analytics Capstone project. My title for the project was a classification of smokers, non-smokers, and drinkers, non-drinkers using hybrid electrocardiogram, ECG, and medical data. My name is Tigis Balacho, and I'm really thankful for my professor Hani Salib for giving me this opportunity to present the second part of the project. In this presentation, the reason why I'm doing this project in the dataset description, in the data techniques used for visualization and model building will be with the rationale will be discussed, and finally the lesson learned and the next steps will be forwarded. When I came to the why I'm doing this project, according to the World Health Organization, in the year 2027, there will be a threefold increase in cardiovascular deaths from when it was 1 million in 2019. There are different risk factors for this cardiovascular disease. Among them is smoking and drinking. In 2019 alone, around 2.6 million deaths were registered from alcohol consumption, and tobacco kills more than 8 million people each year. Even though the cardiovascular disease is preventable, identification of smokers and drinkers is biased and is mainly focused on self-reporting. This depends on only on the willingness from the patient side, and the capability of electrocardiogram in identifying smoking and drinking habits was not used widely, which triggers the importance of this project to build a hybrid machine learning model that classifies drinkers and smokers by combining ECG parameters with other medical records, including demographic data of individuals. For this project, the two datasets were collected. The first is smoking and drinking dataset from the National Health Insurance Service in Korea, downloaded from Kale. It contains around 1 million observations with 24 variables. This provides physiological and demographic factors affecting drinking and smoking status. And the second is the ECG dataset from Iowa University in Korea, again with around 49,649 observations with 13 variables. And this dataset will provide an expanded understanding of the ways in which drinking and smoking affect cardiac health. And these both datasets were pre-processed and cleaned before and after combining them, and using the statistical descriptive techniques, the data understanding and the data types were converted, and missing values and duplicated rows and invalid data types and data were with the outliers were handled properly, and the new features were created, like the heart rate, the body mass index, the mean arterial pressure, and the LER from existing features to get more insights on the data sets. And finally, the target imbalance was checked, and it was found out that it was balanced for drinking status, but is not balanced for smoking status target variable. And for the data techniques and visualization tools, I basically inclined using Python libraries, specifically Matplotlib and Seaborn. And the Matplotlib library will provide me the visualization tools like histograms, scatter plots, and box plots. And the Seaborn was capable to explore more complex relationship of numerical lifestyle factors with ACG parameters utilizing pair plot and heat maps. It will help to understand how various ACG parameters such as the QT and QTC intervals correlate with smoking and drinking status. And for the predictive modeling tools, the logistic regression was selected to be as a baseline model. It works well for classification tasks like predicting smoker, non-smokers, or drinkers or non-drinkers. And the second and the third predictive modeling tools selected are random forest and gradient boosting. These are ensemble learning models that reduce overfitting and improve model robustness by averaging predictions from multiple decision trees. They are capable of handling nonlinear relationships. The other predictive modeling tools are tools used for evaluating model performance, ROC, AUC, specificity, sensitivity, F1 score, and accuracy will be used. And the other is the cross-validation, which is capable to reduce the model performance variance and to check for its generalizability. The lesson learned from this project until now are that problem selection is the crucial step in this project. In dataset identification from different data sources with specified requirement was challenging, but is doable. Finally, I learned how to choose tools for visualization, predictive modeling. And the next step for this project will be using these data visualization and data analysis tools to do the visualization data analysis part, and then developing predictive models, and then so that finally the findings and recommendations will be forwarded. And these are all the reference I used for this project. And now you are able to provide forward feedback and comments on this presentation. And thank you for your time. And this concludes this presentation. Thank you.